good everyone. Today's topic is the electromagnetic spectrum. So I'm going to tell you the benefits and disadvantages of electromagnetic substance equipment. So the first one, I have radio waves. It is used to support radar systems. It is used to send signals to electronic devices. Like now, you have a television. You can watch your television because of the radio waves and everything like that. Your electronic devices too. You have microwave. It's used to support communication. Your phone, your telephones. When you are calling, is something we call microwaves for you to be able to hear from here, and the next person in Abuja or wherever you're talking to is also listening to you. Ultraviolet rays. It is used to stimulate the production of vitamin D. As we all know, in the morning we all like to get the early morning sunshine, and that early morning sunshine is vitamin D. And ultraviolet rays help to produce it faster, so that will be healthy, as we all are right now. It is used to make efficient lighting. In infrared waves, it is used as light vision cameras. We all watch action movies like soldiers. When they are going out for operations in the night, they wear these glasses that make them see. These are infrared waves. And for someone like people that had a fracture and they're healing, it's used for their physiotherapy. It helps them. It produces heat for the reduction of pain. Visible light makes us see images, like the way you and I are seeing each other now. It's visible light. We can see whatever we're looking at. Visible light makes our television, computers, and phone screen work. Basically, you can see whatever is on the TV because of the light that is there. And yeah, there's something we also did in our group for us to be able to see visible light. Now, this is white. It's meant to emit light, like literally, because it's written touchlight, so it's light. So this is a dark screen, and so we'll just put this under so that we'll be able to see what is inside here. Okay, you guys might not be able to see from here, but you can see now. You see me, and you see a picture here. If you come a bit closer, you'll be able to see it. Can you?
Yes.
Oh, you can see from here. So with the emission of the white lights, you can see what is under the screen. Yes? Yes. So now, as we all know, there's obviously a good side of something and the bad side of something. So my fellow group member here will explain the bad side of this.
Okay, so now we have the electromagnetic spectrum, and the elements of the electromagnetic spectrum, as my friend here said, are radio waves, infrared waves, microwaves, ultraviolet rays, X-rays, gamma rays, and visible light. So now we have the bad aspect of this element. So now we're moving on to microwaves. So microwaves can cause painful burns. Like exposure to it can cause painful burns on the skin. And excessive exposure to microwaves can also cause cancer. So it can be cancerous to the skin. For radio waves can cause radiation sickness, and exposure to it can also lead to mutations in the genes. Now, everyone here can remember the Hiroshima bomb. To make that Hiroshima bomb, radio waves were used. That's why the name radioactivity comes in. So, radio waves caused mutations to the genes of the people living in that Hiroshima place, and that's why till today you still see some students or some children being born with some abnormalities and some sicknesses. So now moving on, we have infrared waves. It can cause damage to the eye and skin, and it can also bring about greenhouse effect. Now, infrared waves can cause eye cataracts. I want eye cataracts. Eye cataracts is a disease that makes the eye to continue deteriorating and then until blindness. And that's why you can see this eye. It's meant to be an eye that is red and has all these black patches on it. So now, moving on. We're moving on to X-rays. So now, X-rays can destroy tissues, and they can also be cancerous, as I said earlier, for microwaves. X-rays, too much exposure to X-rays can cause cancer, and that's why anyone that's going for X-rays, like to check their bones or anything, shouldn't do it so often. If not, that person can be prone to cancer. So, gamma rays. Gamma rays are highly destructive and can be used to make nuclear weapons. I'm sure in that Hiroshima bomb, gamma rays were used because it's very, very explosive. And as you can see here in the sketch of the electromagnetic spectrum, gamma rays has the highest frequency, and that is exactly why it is unstable and can be used to make nuclear weapons. So now, visible light. Visible light can bring about pigmentation and thermal damage, and it can also damage the receptor cells in the eyes. And that is why you are advised to not shine a torchlight directly at your eye, because it can spoil your eyes and it can spoil the receptor cells. So now, last but not the least, ultraviolet rays. It can cause alternation to the immune system and can cause sunburn. And that is why we are advised as human beings to not stand directly under the sun for too long, because the ultraviolet rays can harm you and can also alternate your immune system as well as cause sunburns. Thank you very much.
Good day, everyone. We are Group 4, and our group members are Adedoyin Ige, Alabi Israel, Agbara Joel, Petri Norukwe, Famu Agoshola, and I, Adabaya Michelle. Our group is going to be talking about the electromagnetic spectrum. So, firstly, EM waves are waves that can travel through vacuums. And as most of us know, vacuums are basically space. Just think of it as vacuums that can travel in space.
EM spectrum. The EM spectrum is the arrangement of the EM waves. The EM waves, which don't require a medium of transfer, is the arrangement of them. It can be arranged from the lowest frequency to the highest frequency, or from the highest frequency to the lowest frequency. And the way we arrange it according to the highest frequency to the lowest frequency and the lowest wavelength to the highest wavelength. So now we're going to explain each of them one by one.
Firstly, you have gamma rays. Gamma rays are rays that have the highest frequency but the lowest wavelength. So gamma rays can be used to treat cancer, but because they have a short wavelength, when you use the gamma rays, they have to be focused directly on the tumor so that they can attack the tumor but not damage the cells. So when gamma rays are used in chemotherapy, especially brain tumors, the cancer patient has to wear a helmet in which the gamma rays are concentrated directly on the tumor in order to protect the brain cells. Nextly, you have X-rays. So X-rays are the type of rays that they can pass through almost anything. So X-rays can pass through human beings. That is why they are used to look at fractures and dental records. So because X-rays and gamma rays both are very dangerous, people that practice the use of X-rays, that is like doctors, they usually sit down behind this protected area in which the patient has to stay in a place where they are exposed to the X-rays, because X-rays can damage your skin and cause cancer. But the person that is always exposed to it, like constantly, has to be protected in order to protect them. So X-rays can also be used in airports when they are concealed containers to see through and see what is inside them, because X-rays can pass through the medium. Nextly, you have ultraviolet rays. Ultraviolet rays are divided into 3 bands based on their increasing energy, that's the frequency. So you have UVA, UVB, and UVC. So UV rays are found in sunlight, and that is the reason why we have the ozone layer, because UV rays are harmful. So the ozone layer is used to filter through the UV rays so that they don't hit us directly. But as we all know, our ozone layer is breaking down, so the chance of someone getting skin cancer from being outside too long has vastly increased. So to protect yourself from UV rays, you're meant to wear things like goggles or sunscreen. So UV rays are very popular in countries with long periods of sun for shorter times. So exposure to UV rays can cause premature aging and skin cancer, as I've mentioned. But UV rays are also used in hospitals like gamma rays and X-rays because they still have benefits.
Now we have visible light. So light is used in our everyday lives to do different things like reading, moving around so we can see. in the dark. And even in our classroom, we have light bulbs, so that's where visible light falls under. And as you can see, we colored it in a way that it shows the primary colors and how they mix to form secondary colors and tertiary colors. Moving on, we have infrared. Infrared is used in sensors. Infrared waves are transmitted. They come out of human body. So infrared sensors that sense motion. When people move and the infrared radiation comes out from them, the infrared sensors sense it, and those can be used in burglar alarms and things like that. Microwaves, as the name implies, microwaves are used in microwave ovens. So they can be used to transfer heat to the food, and the microwaves do not affect the plastic or the ceramic that you put the food in. They only affect the food. So they heat the food. That's why we can get hot food even after we put it in the fridge. And lastly, radio waves. Radio waves can be used in broadcasting. They can also be used in televisions. So since they have the highest wavelength, they can be used to transmit signals over a long distance and a short distance as well. So this is our project on electromagnetic spectrums. What? Oh, okay. So the wavelength of gamma rays, since it is lowest, the wavelength is 10 raised power minus 11 meters, followed by X-rays. There's a range of the wavelength for X-rays. It's 10 raised power minus 11 meters to 10 raised power minus 9 meters. For ultraviolet rays, it's 10 raised power minus 9 meters to 4 times 10 raised power minus 7 meters. Visible light, 4 times 10 raised power minus 7 meters to 7 times 10 raised power minus 7 meters. Infrared, 7 times 10 raised power minus 7 meters to 10 raised power minus 4 meters. Microwaves, 10 raised power minus 4 meters to 10 raised power minus 1 meters. And radio waves, greater than 10 raised power minus 1 meters. They have the highest. Then frequency, gamma ray has the highest frequency. So it's 3 times 10 raised to power 19 hertz. For X-rays, 3 times 10 raised to power 17 hertz to 3 times 10 raised to power 19 hertz. Ultraviolet rays, 7.5 times 10 raised to power 14 hertz to 3 times 10 raised to power 17 hertz. Visible light, 3 times 10 raised to power 14 hertz to 7.5 times 10 raised to power 14 hertz. Infrared, 3 times 10 raised to power 12 hertz to 4.3 times 10 raised to power 14 hertz. Microwaves, 3 times 10 raised to power 9 hertz to 3 times 10 raised to power 12 hertz. And radio waves, less than 3 times 10 raised to power 9 hertz. Thank you.
Good day, everyone. The topic for our group is recycling. So we're going to start off by singing a song. If you know it, sing along. Reduce, reuse, recycle. Reduce, recycle. So as you can see, we have two things in front of us. We have a basket and a cupboard. So when we're doing this project, we had some leftover cardboard. Instead of throwing them away, we use them to make useful things that we can give Mr. Luada to put in the lab.
Okay. I'm going to start off with recycling in relation to physics. Some people might ask that, is it possible? So first thing is gravity. Now, gravity is the force that pulls us down towards the earth. It is probably the simplest way we can separate out our recyclable materials. By positioning a series of holes and spinning discs, we can let items filter through something that looks like a giant sieve. So what that means is that we're going to put two different sizes of discs together. We're going to have holes in the middle. Then large items will make it through the larger holes, while small items will make it through the smaller holes. By shaking it, the heaviest items will fall, while the lighter items move up. So we use that law of gravity to separate different things. We can separate plastic and paper. So then we have magnetism and conduction. We also need to separate different types of metals. There's no point of melting down aluminium and steel together because it won't produce a pure result. But for any other different metals at different temperatures. So we use the law of physics to help us separate metals too. So different metals have different magnetic properties, which makes them easy to stick to magnets. So we can separate the different types of metal by using a magnet. Then also conduction. Metals are conductors of electricity and can create magnetic fields in an area. We create electricity inside the metal recyclable. We can use the nature of the electricity to separate the rest of the metals by type using a machine called eddy current separator.
So all materials take energy to create, and producing that energy puts greenhouse gases into our atmosphere. And we know that when greenhouse gases enter the atmosphere, it destroys the ozone layer, like the other group said, and that is what helps filter the UV rays. So without recycling, we're destroying our atmosphere and putting ourselves at risk. So these are the 6 R's of recycling. Reduce, which basically means we should try and lower the level at which we use those materials that cause harm to our society. Reuse, we should try and use them again after use. So if you have a plastic bottle, instead of just trashing it, we should try and use it again and again and again until the lifespan has ended. Refuse, which means you should try and lower the amount of use of those things. If someone offers you a glass drink or a plastic drink, you should say no. Maybe you want it in a metal bottle. Rethink, which means you should think about other ways in which you can recycle those materials. Like now, this cardboard, you could have just thrown away the carton into the dustbin, but now I've used it to make a cupboard, which is going to be used in the physics lab. Repair, which means if something spoils, you shouldn't just trash it. You should find the best way to try and fix up that thing so that it can be reused again. And recycle, which is the general saying for all the remaining 5 R's. So what is recycling? Recycling is a way of recovering materials such as metals, paper and cardboard and plastics, which can then be used to make new products, like I've said before. Steps to recycling materials: collection and processing. So you collect all the, let's say for now, plastics, collect all the plastics and process them, maybe melt them, then remanufacture them into newer plastic bottles. Then purchasing the new products that have been made from recycled materials so that we can just keep on going in that same cycle. So by recycling garden products and planting trees, you can help improve the environment in the back of your house. So now I would like to call 3 members of the class to dip their hand into the recycling bin. Petrine. Now read the facts.
Recycling reduces our dependence on imported raw materials.
Anissa.
Aluminium cans are melted down to make new products.
And Hansley.
Recycling helps conserve our non-renewable resources.
Michelle.
Paper recycling is very common.
And our teacher, Mr. Oluwadara.
Enough metal was recycled from old corsets to build 2 warships. That's interesting.
Yeah. And everything inside they were made out of scrap cardboard from after we made the project. So that's why it's a recycling bin. Thank you.
Good day everyone. We're group 3 and our topic is pulley system. So firstly, what is a pulley? A pulley is a machine that consists of a system of ropes and wheels. The wheels revolve in a frame set, and each frame has a grooved run that allows the rope or cable to pass through. Okay, so according to physics, back then people saw the wheel and saw the axle and said, okay, why can't we just put it together and form something? They now said, okay, wheel plus axle equals pulley. That's how the pulley system was formed. Now to the types of pulleys. First, we have a fixed pulley. In this pulley system, the frame is anchored to a point. Hence, to maintain the tension of the rope or the cable, the pulling force on the one side, which is called the effort, must be equal. Okay, so a fixed pulley. This is when like the wheel is hooked to a frame so that it stay in one place, so that the tension, so that the effort and the load will be equal and the movement will be synchronized. Second one, tackle and block and tackle system. So in this system, you have two or more fixed pulleys. One could be mobile while the other one is immobile. And the pulleys are usually mounted to one frame to achieve a higher velocity ratio for better movement.
So, there are different uses of pulleys in the modern system. Pulleys in the olden days and still recently are used in wells. A well uses a fixed pulley to be able to move the bucket up and down. And in those days, it was just the fixed pulley that was used. It was just the fixed pulley that was used. But nowadays, there are more things that add to it so you can reduce the effort of the person pulling the bucket out. Pulleys are used in cranes. In the mechanism of a crane, there are more than a lot of pulleys attached to it. There can be fixed pulleys, movable pulleys, block and tackle pulleys. There's plenty pulleys put together to make a crane. In a fishing rod, in order for the fishing line to get the deepest and farthest ends of the sea, or lake or ocean, the pulley used is a movable pulley, the one that moves around the fishing hook. And then, we didn't say this before, but then there's a third type of pulley called the movable pulley. And this pulley is very complicated, but unlike the rest, it reduces the effort required. So if you are going to use a particular amount of effort for the fixed pulley, in a movable pulley, you won't use that same amount of effort. And this may not be much, but this is so you can see how a pulley works. And we also have another model that isn't working, but this is how a pulley in a well looks. Then they'll put the bucket here, and then someone else at the other end is dragging it out. This one is moving, and the ropes, they're rolling. And this one is like, it works. If you put something here to drag out, I can drag it, and this one is going up. So you're bringing this out like that, and then you can drop it back by reducing this line. So you can drag it and put it back. That's how a pulley works. And very importantly, did you know that the velocity ratio in a pulley system, it depends on the number of pulleys in that system. So if there's only one pulley in that system, the velocity ratio is 1. If there are 2 pulleys, the velocity ratio is 2. Exactly. Thank you.